Hello friends, in this video lecture series I will be talking about organic NAMB reaction, particularly the Baeyer-Villiger oxidation. What happens in this reaction is ketones are oxidized into esters, so the insertion of oxygen takes place between symmetrical or unsymmetrical ketones in the presence of a peroxyacid. It could be MCP, Ba, or any peroxyacid. So peroxyacid is something which contains extra oxygen. As you can see, if there was no this oxygen, that will be a normal carboxylic acid, but if we add one extra oxygen, that's why we are calling it peroxyacid. So what happens is your starting material is ketone and you are reacting this ketone with peroxyacid. This oxygen is transferred to this ketone and you get ester functionality. So this is how you convert ketone into esters using Baeyer-Villiger oxidation, and this is called FGI, functional group interconversion. So you are converting one functional group into another. In this case you are converting ketone into ester. So one more important thing in this NAMB reaction is the more electron rich group migrates to the oxygen. So the migratory aptitude or migration ability is determined by the electron richness. So tertiary alkyl has higher migratory aptitude than secondary alkyl group, and then aryl has higher, and then one primary alkyl, and then least is the methyl. So we will discuss this migration in the mechanism, and we will discuss the Baeyer-Villiger reaction oxidation mechanism. But the important thing is the migratory aptitude is really important. So which group is going to migrate is determined by this sequence, like tertiary is more than secondary, and then aryl than primary. So have a look at this mechanism of this reaction. So you have a ketone. So these are the lone pairs which are more nucleophilic in character. They are going to pick proton from this peroxyacid, and this bond between oxygen and hydrogen breaks in the favor of oxygen, and oxygen gets a negative charge as a result, and this oxygen, when picks proton, gets the positive charge because oxygen makes 3 bonds. So this is called now next step is this then a take of this nucleophilic oxygen on the electrophilic carbon, and when this oxygen attacks on this carbon, this bond shifts in the favor of oxygen, and you have this intermediate. Now the next step is, this is called the migratory step, where the migration takes place. So this R2 group, if it's tertiary, it has more migratory aptitude. If it's secondary, then aryl, then primary, then methyl. So this is a migration step. So R group, the more electron rich R group migrates to the oxygen to stabilize it. So this R group is migrating towards this oxygen in this case, and then this bond between these oxygen bond breaks, and we have a carbon double bond oxygen, and this bond breaks in the favor of oxygen, and this oxygen attacks on this peroxyacid, and you get the acid group as a byproduct, and you are having a the anionic oxygen esteric form. When this negative charge on oxygen attacks on this compound, it takes proton, and this bond breaks in the favor of carbon oxygen. Then this bond is shift towards oxygen, and this is a resonance forms of this compound, and as a result, in the last step, what happens is this proton is picked by this peracid, and this is a double bond formation between carbon and oxygen, and this bond shifts in the favor of oxygen. So this is how you get the ester. So when this double bond shifts towards oxygen, you are having a OR group, which is this. When this bond between oxygen and hydrogen breaks, you are having a carbon double bond oxygen, which is this carbon double bond oxygen. So this is the esters. So you started from ketone and you finish at ester. So this is how Baeyer-Villiger oxidation takes place to form esters, and the key step in this reaction mechanism is the migratory step. So the migratory aptitude of this R group is determined by the electron richness. So I hope you understood this reaction mechanism. For more amazing videos, please subscribe this channel and don't forget to click on the bell icon. Thank you. Bye.